Welcome to CIST 2611, Chapter 1, Network Defense and Countermeasures. In this chapter, we're going to identify the most common dangers to networks. We'll understand basic networking, also employ basic security terminology. We'll look at the best approach for network security for an organization. Evaluate the legal issues that will affect your network as a network administrator, and also use resources available for network security. So this chapter, as well as the entire textbook, it will refresh your understanding of basic networking concepts. It also provides an overview of actual threats posed to a network. This chapter also gives a high-level overview of the entire book. It will introduce topics, refer to other chapters with more detailed information on specific topics. This chapter will introduce you to some important security-related terms used by networking professionals and hackers, and also list resources and information on network security. So as the internet has grown, it's also brought a way that many networks can be compromised and data can be stolen. There are legislation that legislators are working on ways to prevent identity theft. It's an ongoing process. As we go through this chapter, some of the concepts you will need to understand is basic networking structure, data packets, IP addresses, uniform resource locators, MAC addresses, protocols, some basic network utilities, and the OSI model. So when we look at basic network structure, keep in mind that the fundamental purpose of a network is for communication. Now that network is going to be made up of also of hubs, switches, routers, and also firewalls. And the architecture for the network comprises the format of which these devices are connected. Data packets, that is the package that holds the data and transmission information. The sizes are going to range between 32 and 65,000 bytes. It's usually ultimately formatted in binary. Some things that are going to be included in the packets include the source and destination IP address, the packet size and type, and also data and other header information. Next, we'll look at IP addresses. The IP version force, with those are a series of 4 3-digit numbers that are separated by period. As we see the example for the first byte. Networks can be private or they can be public. Certain ranges are going to be private. That's going to be used in a network. There are also an IP version 6. That's going to use a 128-bit address and hex numbering, as we see the example on the screen here. The URLs are text-based web addresses. As we see here is like chuckeastham.com, the author of the book. It's going to translate to an IP address. You can use the IP address or you can use the URL to access a website. The translation is going to be performed by domain name service. It is a lot easier to remember google.com than it would be to remember the IP address. MAC addresses are unique hardware addresses. Now, your network interface cards, they're going to have a unique MAC address, which will be a 6-byte. Some of our protocols we'll be looking at, these are the standards of network communications. So the examples of these include the file transfer protocol, the FTP, Telnet, HTTP, POP3, and so forth. In your textbook, when you reach the basic network utilities, that section is going to provide an overview of the basic network utilities of ipconfig, which shows detailed information. You can use this with the ipconfig. For example, ipconfig space/all. They'll display the network configuration. Some of the things you can do is display network configuration, refresh the DHCP DNS settings. If you don't have any parameters, the ipconfig will display the IP address, subnet mask, etc. You can use this to set an IP address for a machine. You can use it to release an IP address or renew an IP address as well. Ping is used to test a network connection. So you can type in ping and then the IP address and test whether you can actually send and receive information back from that address. All right, traceroute, that'll find the IP address of any remote host. It's useful for troubleshooting large networks, especially where you got networks that several paths can be taken to route at the same point. NetStats is going to display network statistics. So those are your basic network utilities. The OSI model is the Open Systems Interconnect model. With this, you'll see that you have it broken down into 7 different layers. You have a physical, data link, network, transport, session, presentation, application. So when we look at this, the physical network, that's the physical properties of various communications media. The data link, that's the logical organization of data bits that's transmitted on that particular medium. Network is the layer that has routes the information in the network. Transport provides end-to-end communication control. Session is going to provide the mechanism for managing the dialogue between end user application processes. Presentation layer relieves the application layer of concerns regarding some tactical differences with data representation. An application, that layer interfaces directly with the applications and performs common application services for the application process. So you got yourself, what does this mean for security? Now I want to make sure that you understand that by understanding the OS model, that is essential in developing a secure network. If you understand the information details of how a network is structured, this will help troubleshoot complex security issues. For example, you may know how to drive a car, but it doesn't really help you fix a car if it breaks. You need to know more detail about how the car works to efficiently troubleshoot any issues. Now, a lot of this, like securing the data and network devices, they'll be covered in the later chapters. That's the basic purpose of this whole book. That's to secure the data and the network devices and allow communications between and among organizations. Going back, we look at the 3 points of attacks we have. You have the data itself, the network connection points, or the people. And there are 3 main areas of concern. Those are 3 focus areas of security. So we're assessing the likely threats to a network. There are multiple facets associated with establishing threat levels. Keep in mind, though, that the methods used to assess potential threat levels is not an exact science. We have 3 factors that are used in assessing the likelihood of a threat, and we'll cover these later on more in depth. Right now, know that they are the attractiveness of the system to hackers, the nature of the information on the system, and the traffic to the network system. So when we look at security, though, we really have two ends of the spectrum. We have those that think there's no real threat, there's nothing to worry about, and we also have those that are extreme, that all hackers are experts out to break into my network. So looking at one end of the spectrum, those that say there's no real threat, they take a relaxed attitude towards security. This promotes a reactive approach to security, and oftentimes security measures are not put in place until after a breach has occurred. This is something that must be avoided at all costs. You have to be proactive, not reactive in security. On the other end of the spectrum, that the world is full of hackers that are out to get me. Lesser skilled hackers are more pervasive. They will target smaller companies. Usually the experts are going to seek the high profile networks, the big value targets, the financial, or maybe it's something that the ideological gains are there. So when we look at security, we really have to take a realistic approach. That's the only practical approach. That's to find a moderate solution between the two extremes. So we start looking at the different types of assessments to our system. And we have many factors that we need to be addressed in this assessments. We look at the three most common threats to networks. Those are intrusion, malware, or blocking or denial of service. So these are threats, whether it's a virus, a worm, denial of service attack, social engineering, they're trying to get access to our system. We have to ask ourselves about the likelihood of attacks. So in here, we're going to look at identifying factors involved in assessing the likelihood of an attack. Now, in this, we should consider using a rating system. So we're going to provide an introduction in this chapter of the rating system, but that's going to be covered more in detail in chapter 12. So an administrator should ask himself a couple questions. What are the realistic dangers? What are the most likely attacks for our network? What are some common vulnerabilities? And what is the likelihood of an attack? Okay. As we had mentioned previously, that the threat assessment factors we consider are the attractiveness of the system, also the nature of the information on the system, and then the traffic to the system, which could be considered the security devices in place. So we look at this, say the attractiveness, information contents, security devices present. Keep in mind though that this is not an exact science, but you can use a numerical scale to be assigned to each one of these factors. So attractiveness, we'll assign the variable A. We'll assign it a value between 1 to 10. Information contents, I, value of 1 to 10. And the security devices is got the variable S, and we decided the value of 1 to 10. So then when we perform our threat assessment, we take our attractiveness and information content, we add those values together and then subtract our security. And that's going to give us our vulnerability score. Lower the score, it will indicate a lower risk. Keep in mind that that is not an exact science. We do have some security terminology and hacking terminology. You need to make sure that you go through, look at the definitions for these terms, and that you are well aware of those terms. So just like any other occupation, security personnel need to understand the language used by people in the field. So we got, like I said, two basic cultures here. We have our hackers, we have our security. Those that are going to exploit the system and those that are trying to protect it. So it helps you to protect your system if you know the terminology used by the hacking community. But keep in mind, though, that this is something that's constantly changing. New words are being invented constantly. We have bluejacking, which sends unsolicited messages to Bluetooth enabled devices. It's a fairly new word. I also want to keep in mind that not all IT security issues are technological solutions or have technological solutions. IT security is about 1/3 technology, 1/3 business, and 1/3 sociology. So social engineering is by far the tool of choice by most crackers. You can obtain an ID and a password faster, easier, and with less risk over the phone than by using a computer. The way around that is training. You want to make sure that people are trained of how to use technology, how they should respond to questions, that they don't willingly give up their information. So when we approach network security, we can be proactive versus reactive. Thinking of this, the parameter approach to security that's focused on the perimeter devices. Internal devices are still vulnerable. That's such devices such as firewalls, proxy servers, password policies. Now, that leaves the inside vulnerable, but the outside is more secure. Layered approach, that focus includes both perimeter and individual computers within a network. So in that, the perimeter secure, selected systems within the network are also secured. And a hybrid is a combination of multiple security approaches. So in this, the approaches overlap or combined to tighten security. This is something that's the typical approach in the industry. Think of it as accessing a bank safety deposit box. You have multiple levels of security that you have to go through to get to that bank deposit box. You got the doors of the bank building that have locks. You've got the lobby with may have armed guards. You have the vault that's got a big lock on it. Each door in that vault is going to have a lock, maybe a 2-key lock, where you have one key, the bank has the other key. Not to mention you have to interact with tellers, maybe bank managers and so forth to access that. So that's a hybrid. That's where you have a combination of multiple securities to secure your network. There are some laws that govern how organizations' data and networks must be protected. The Sarbanes-Oxley Computer Security Act 1987, and the one that most everyone is more familiar with is the Health Information Portability and Accountability Act, or the HIPAA Act. Now, keep in mind that IT security needs to protect systems that's not only from hackers, but also from untrained users, disgruntled employees, and even lawyers. Some lawsuits can damage a company just as badly as the loss of computer or the temporary loss of the data. Lawsuits can even put CEOs in jail if their IT department didn't perform due diligence. So you want to make sure that you follow the laws that are governing your organization. There are also some security resources that are available. CERT, Microsoft Security Training Center, or Microsoft Security Tech Center, F-Secure Corporation, SANS Institute. I personally like the SANS Institute. If you have a question about a policy, how a policy should be laid out, or you need a template for a policy, SANS Institute does have a great policy template. So to sum up the chapter, the most common dangers to networks are viruses, worms, and Trojan horses. We covered the basic security terminology, hacking terms that deal with people and activities, security terms deal with devices and policies. It is wise to know both of those. We looked at the different approaches to securing your network, where it's proactive versus reactive, using the perimeter, layered, or hybrid. We looked at some legal issues and also some resources that were available for network security.